you how to interpret position and velocity time graphs and how to change from one type of graph to the other. First, let's get some vocabulary out of the way. Some of the variables we'll deal with are vectors and some are scalars. A basic definition of a scalar is just a number. So 2 is an example of a scalar. The basic definition of a vector is has magnitude and direction. So 2 miles an hour north is an example of a vector, whereas 2 miles per hour is an example of a scalar. And some of the terms we'll be using on the graphs include position, which is a vector. I indicated that with a V, and it simply means a location. It's a vector because it is a position relative to an origin of a coordinate system. Displacement is the change in position, which written in symbols is delta x. Position, written in symbols, is just an x. And the arrow over the top indicates that it's a vector. Velocity is the rate of change of position, or, in a different way, how fast in a specific direction. And the symbol for velocity is a V, also with an arrow over it to indicate it's a vector. Acceleration is a rate of change of velocity, and the symbol for that is an A, also with an arrow over it to indicate that it's a vector. Now, if we consider first a position time graph, because that's the simpler of the two, and we consider an object that is standing still, then let's think about the different things that are true of an object that is standing still. First of all, if you're standing still, your velocity is going to be 0, and it's going to be a constant value of 0. So it not only starts at 0, but it stays 0. And your displacement, so your change in position, is also going to be 0. Because if your velocity is 0, you're standing still. You're not going to be moving. And your change in velocity is 0 and constant, so is also going to be 0, which means that your acceleration is equal to 0. So a graph would be a horizontal line at the location that describes your position. Now let's think about an object that's moving at a constant speed in the positive direction and an object that's moving at a constant speed in the negative direction. If we think about an object that's moving in the positive direction and we want a constant speed, we can say the velocity is not equal to 0, but it is a constant. So it's not going to change, which means delta V, so change in velocity, will equal to 0. Acceleration will equal 0, because the value is constant, but it's not changing. We can also say that the displacement of the object will not equal 0, because the object is moving, so it's going to have some sort of displacement from start to finish if it is moving at a constant positive direction. If we consider the same thing for the constant negative direction, we can still say velocity is not equal to 0, but it is a constant. Change in velocity, because it's constant, will equal 0. Acceleration will equal 0. But the displacement will not equal 0 because it is moving at a non-zero speed, so a speed not equal to 0. So if we look at what those are going to look like on a position time graph, if we have a negative slope, so this one in blue, this one is constant, negative velocity, and this one is constant positive velocity. And the steeper the slope, the faster it goes. So the slope is equal to the velocity. This has an increasing rate of position. That's a positive velocity. This has a decreasing rate of position. So that's a negative velocity. Now let's consider an object that is accelerating. So an object that is accelerating, let's think about our terms again. V will be changing. And that could be increasing or decreasing. And it could be increasing in the negative direction, increasing in the positive direction, decreasing in the positive direction, or decreasing in the negative direction. So we have 4 choices about how it can be changing. And it will have a value of acceleration, and it will have a value of displacement, so nothing will be equal to 0. So let's take a look at each of our 4 options. All right. So if we look at this graph, it goes from a very small slope here to a very steep slope here. So think of it this way, it goes from slow to fast. And if we're going from slow to fast, so gentle slope to steep slope, then we're getting faster, so we are speeding up. And we're speeding up in the positive direction. If we want to find the slope of a line at any point along the curve, what we would do is draw a tangent line to that curve. So the slope of this line right here would indicate the velocity at that point on the graph. So continuing on, let's see what else we got here. Get these blocks out of the way. So if we look at this one, the slope starts gentle, so slow, and goes to steep, fast, but it is inclined in the negative direction. So if we consider a tangent line partway through, that tangent line has a negative slope, so this is speeding up, but this time in the negative direction. And then we have 2 more. So there are 4 possible ways to accelerate. Now we'll go from steep, which is fast, to more gentle, close to horizontal, right? Horizontal 0 slope, which is slow. So fast to slow is slowing down. And the slope of our tangent line is positive. So this is the positive direction. Then one last one, the one that we haven't done yet, which is steep, which is fast, to gentle, which is slow. And this goes fast to slow, so slowing down. And if we look at the slope of our tangent line, if I draw a tangent line in right here, then you can see that it has a negative slope, so in the negative direction. So to recap, looking at the 2 graphs, if I have a position time graph, the slope is equal to my velocity. The y-intercept is equal to the initial position of the object, and the change in y is equal to the displacement. So if we look at an example, on this example, the y-intercept would be this value on the y-axis right here, where the function crosses the y-axis. The slope would be rise over run. So if I go this, like this, it's how far up did you have to go divided by how far over you have to go. That will give you your slope. That will give you your velocity. And this is inclined in a positive direction because it goes up is positive and over to the right is positive. So your slope will end up being positive. And your change in y will simply be your initial position here and your final position here. So displacement, change in y, will be change in position. Remember, that's x is our position variable, equals xf, which is final, with an arrow to indicate a vector, minus x initial, which is where it's starting, to get the value for displacement. Then, to look at the velocity time graph, let's go through the same sequence. So if we have an object that's standing still, we know that if it's standing still, the velocity is going to be 0 because it's not changing. Its displacement is going to be 0 because it's not moving. Its acceleration is going to be 0 because its change in velocity was 0. So if we draw that as a graph, we get a line, and the x-axis is underneath here. We get a line, horizontal line, on the x-axis. Now let's consider an object that's moving at a constant speed in the positive direction. So constant positive direction, we're going to say the velocity is not equal to 0, but it is constant. Its displacement cannot equal 0 because it's moving from one place to the next. Its change in velocity does equal 0 because if it's positive 10 minus positive 10 is 0. So regardless of how fast it's going, it's not changing, so it's 0, which means its acceleration will be 0. And then if we look at an object moving in a constant negative direction, the velocity is not equal to 0. The displacement is not equal to 0. The change in velocity is equal to 0 because it's not changing, which means the acceleration, which depends on the change in velocity, will equal to 0. So it will look like this. And if we look at the top one, this is above the x-axis. Here's our 0 on the y-axis here. It's above the x-axis, so this is a constant positive velocity. And this is a constant negative velocity. And it's not changing because the velocity is not changing. So the y value won't change. Therefore, it's plotted as a horizontal line. Continuing on, if we have an object that is accelerating, then our velocity is not equal to 0. Our change in velocity is not equal to 0. Therefore, our acceleration is not equal to 0. And we get four possibilities, because remember we had four possibilities for acceleration on the position time, four things. So let's take one at a time here. First, the red. So if you look at the red line, it is going from 0 and getting faster. The value is getting farther away from 0 because it's getting farther away from the x-axis. That means it is speeding up. And it is above the x-axis. So here's 0, here's the x-axis. That means it's moving in the positive direction. This pink line is also moving farther away from 0. So this is also speeding up. But it is below the x-axis, so it is in the negative direction. The yellow line is coming from a higher value closer to 0, so it is slowing down. It is above the x-axis though, so positive direction. And the blue line coming from farther away from 0 to closer to 0, so slowing down. But it is below the x-axis, so it is the negative direction. So to summarize, on a velocity time graph, the slope is equal to the acceleration. And to find the displacement, we find the area under the curve or under the function. So now let's look at a couple of pairs of graphs together. So starting from the most simple, if you have a position time graph, and remember your x-axis is down here, on the velocity time graph, the x-axis is right underneath that line there. A horizontal on a position graph will be a horizontal line on the x-axis on a velocity time graph. If you have a diagonal line on a position time graph, then you will have a horizontal line on a velocity time graph, but not on 0. The slope here will give you the y-intercept for this graph. So our next, and same thing, so if you have a negative slope here, our slope here will give you the y-intercept. And you'll notice a negative slope will be underneath the axis, underneath the x-axis on a velocity time graph. And if we have a curve on position time, and this curve goes from slow to fast, so the velocity is increasing if we think about the slope of the tangent line in the various parts of the graph, then the velocity will be increasing, coming farther away from 0, and will be a diagonal. And that is how you interpret position time graphs.